Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bay. Then before that, bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. Our topic today is after the repair, resets and relearns. So a couple months ago, we did after the repair, talking about coding, and this time we are going to talk about resets and relearns because there are a few different terms for these types of things we're talking about that sometimes they get a little confused between what one is and what another one is, and as far as capabilities and things. So resets, relearns, coding, like I said, we talked about earlier, programming and flashing. I hear these terms used a lot, interchangeably sometimes. But like I said, this time we are going to focus mainly on, or exclusively on, resets and relearns. So first one is resets. So how do we define what a reset is? So resets are used to reset a parameter back to factory specifications. So it's some sort of an adaptable, movable parameter that it needs to be reset back to factory when a new part is replaced, generally speaking. So some examples are like an oxygen sensor heater circuit as it adjusts as the uh, uh, heater circuit wears. It'll adjust the amount of current flow through that heater to allow it to heat up faster or as fast as it used to. But then when you put a new oxygen sensor in, it's going to have that excessive amperage flowing through it, and then you could burn out the heater. So what you need to do is you need to reset that back to the factory level, and then everything will just kind of relearn where it needs to be. And same thing with transmission shift adapters. If you think about any time you do any transmission work, it's going to shift differently. Uh, do any valve body work, solenoids, bands, or whatever. As the transmission adapts, it's going to adapt to whatever the wear level of the transmission is, all the parts inside. So if you do replace new parts, you could have harsh shifts, things like that. So you need to reset the transmission shift adapters. Usually, as we're going to see here over the next few slides, it's pretty quick and pretty simple, but it's just the fact of you need to make sure that it gets done. You need to make sure you do this at the end of the repair. Otherwise, you may end up replacing that part again, and we don't want that. So first example is on this oxygen sensor heater. So on a good portion of our scan tools, any of the intelligent diagnostic tools and the Veris Edge, it's going to have the service resets and relearns quick link that's in there. So what that is yes, those resets and relearns are already in the tool. They're in the individual modules, but this is set up as more of a quick menu. So you can go in and just find what job did I just do on this vehicle and is there a reset or a relearn? So it's going to give you both the resets, the relearns, and also any bidirectional functional tests that you'll need. So in this example, we're on a Tahoe. And we'll go in there, and for that, we see replace and relearn oxygen sensor. That's pretty much most GMs from '06 and newer need this done. And as I said, over time, it just adapts the current flow going to the heater circuit. So we do need to reset that, reset that back to factory spec. So we go in there, And then in this example, we have the oxygen sensor heater learn right here down the bottom. So we'd simply select that, and it says on the next screen, select reset. We'll hit continue. And then there's a little reset button up there. You would click that. As soon as you're done with that, it's done. So by and large, resets are just a quick, I'm just going to click this. It's going to set it back to the way it started at the factory. And then I can go and go on my way. Next one's transmission adaptives, as we mentioned earlier. So if we look in the repairs, this is a 2017 Acadia. It's going to installing some parts on the valve body, right? So if I replace the valve body for transmission control programming and setup, refer to that. That's a totally different topic, right? The programming, as we said, or flashing. But we're talking about resets. So after we've done that, we also need to do a reset transmission adapt. So we can refer to that article to do it, or we can just go on our scan tool, and then we find there's a transmission adaptive pressure reset. We can go in there. It's a simple procedure once again. Clearing taps function should only be performed after an internal repair or replacement of the transmission. Refer to service information and follow all required steps. Continue. And then once again, this is just a simple hit on the reset, and then it's reset, right? So it gives you the data so you can see where it was, but then all you got to do is reset it. Just basically resets at the default values, and the test will be complete, and we're done. So resets, like I said, fairly straightforward. Usually it's going to be that clicking a button on the screen, and really not a lot of other things that need to be done along with it. Relearns are along the same lines, similar vein, but oftentimes they're going to take a little bit more time. They might even have require an action from you, or it's going to be an action that is actuated inside the vehicle. So relearns are used to teach the ECM parameters of a replacement part. So for example, a throttle body relearn, valve body relearn, or TPMS relearn. So throttle body relearn, right? So if I'm on a drive-by-wire vehicle, which pretty much any vehicle nowadays is, the computer needs to know what is the extent of travel. Where is 100% on this particular throttle body? Because they're all going to be just that little bit different, right? So where is 100%? Where is 0%? So it's going to cycle it back and forth and see what is the range of travel. Valve body, it's going to see, how are these solenoids reacting? Because if you change the solenoid, it could have different characteristics than the solenoid that was in there before. No matter how slight, we still might need to do that. And then same thing with TPMS, right? We rotate the tires, or replace the tire, or replace the sensor. The ECM needs to know, well, what frequency is this one, or what is the serial number of this tire pressure monitoring sensor. So first one we have is a 2012 Nissan Murano. That's fairly common. Nissans in general seem to be fairly common with the throttle body. But if we go into service resets once again, and you'll see we have an example for perform idle learn procedure, or we could do replace and relearn throttle body as well. But there's an idle air volume learn that needs to be done. So it needs to know where is that going to be at idle. So we go to idle air volume learn. Idle air volume learning is a function to learn the idle air volume that keeps the engine idle speed within a specific range. It must be performed under any of the following conditions. Actual vehicle applications may differ, but each time the IACV and AAC valve, throttle body, or ECM is replaced, idle speed or ignition timing is out of specifications, needs to be done then as well. So anytime the idle air control valve, throttle body, or the ECM is replaced, this needs to be done to teach the ECM what the parameters are of that part. They continue. Then it says perform accelerator pedal release position learning. Actual vehicle application may differ, but make sure the accelerator pedal is fully released. Turn the ignition switch on and wait at least 2 seconds, then off for at least 10 seconds, on for at least 2 seconds, and then off for 10 seconds. Closed learning. I'm going to make sure the accelerator pedal is fully released, on for at least 2 seconds, off for at least 10 seconds, and then confirm the operating sound of the throttle valve during that 10 seconds. Before performing the idle air volume learn, make sure that all of the following conditions are satisfied. Learning will be canceled if any of the following conditions are missed, or even a moment. So this is where people will run into issues trying to do this, and they'll think, oh, the scan tool's not doing it right, or something wrong with the car. These can be very specific as to what they need. So, for example, battery voltage needs to be more than 12.9 volts at idle. Hopefully, it would be. Otherwise, you probably have a bad alternator. But it's got to be more than 12.9 volts at idle. Engine coolant temperature needs to be between 158 to 212 degrees. So, if it's running a little hot that day, not going to work. If I just turned on the vehicle and it's cold, then it's not going to work. You need to have it warmed up to the proper temperature and all that. Gear selector and park are neutral. All electrical loads off. That includes AC, headlamps, rear window foggers, cooling fans, etc. For vehicles equipped with daytime running lights, set the parking brake and the lights will go off. Steering wheel straight ahead, centered. Vehicle speed stopped at 0 miles an hour. Transmission warmed up. Drive the vehicle for 10 minutes. So the vehicle does need to be warmed up. So that kind of solves the problem of the coolant temperature as long as it's not running too hot. Key on engine running. Idle is not excessively high. All non-idle related codes need to be cleared or repaired as well. So if any of those are out of spec, it's going to fail. It's not going to work. So once that's all good, we can continue. If all conditions are met, select continue to start the test and then wait for the test completed screen. So we would hit continue and then it's going to say test in progress. And then of course we would wait for the test completed and we would be done. But that's just one example because I hear people struggle with that, especially on Nissans and then also on GM vehicles. They can struggle with that too. Same type of thing, or even the automated EVAP test on GMs, which isn't really a reset, it's a test, but there are specific functions and settings that need to be there in order for that to work. Let's move on to TPMS. So here's another example, once again, with Nissan. Nissan seems to have some quirks about them with some things. So for TPMS, if I need to register a tire pressure monitor sensor, we can do it one of two ways. We can do it with the transmitter activation tool, or we can do it without a transmission actuator tool. Now, with the tool, it's very simple. You just go around the tires, and we're going to show that in a second. The other way, I have to set my tires to a specific pressure and then drive it. And when it senses, oh, there's 36 pounds in the left front tire, then it knows that's the left front tire. 36 pounds in the tire. It recognizes it as the front left, for example. But in here, we're in our tire repair quick lookups. So we can also go to functional reset right from here, and it will pop us into the scanner. And then we go under functional tests. And then there's actuator tests, which would be like testing the lights and things like that. But you see, we have TPMS registration with the J45295 and TPMS registration without the J45295. So let's assume that we have one of these tools, which would be, for example, if you have a snap-on tool, it's a TPMS 4 or TPMS 5. TPMS 3 would do it. TPMS 2 would do it. TPMS 1 would do it. So depending on how far back you go, all of them have this actuation function because it's been needed since the beginning. So the example, you see the little antenna sign right there, and there's a little antenna sign right there. That's the actuating antenna. You just hit the button, and then it'll make it actuate, and it'll excite the sensor, and then it'll go. So it says this function is used in conjunction with the J45295 TPMS tool or equivalent to register the tire pressure transmitter IDs. Note 14 and 15 rogues use a signal of 433 megahertz to activate the sensors, and the J45295 will not generate a signal. Snap-on TPMS tool or equivalent must be used to wake up the TPM sensor. So the snap-on tool will do either of the frequency. Procedure will only be carried out successfully using the correct tool. Ensure the key is on and engine is off. We'll continue. Perform the registration in order. So left front, right rear, left rear. So we're just going to go clockwise around the vehicle, starting at the left front. The lamp will flash when the procedure is started. Place the TPMS tool against the rubber of the tire in the area of the valve stem, not against the rim. That's important for any vehicles where you need to do this because the rim could cause interference. So you want to put it on the rubber part where it'll be getting to the back of the sensor. Press the TPMS tool start button once. Green LED comes on. Wait for tail lights to flash and green LED to go out, and the tire is now registered. Perform the same procedure on the remaining tires. So you're going to go around, wait for the tail lights to flash. TPMS lamp goes out and test completed displays on the scanner only if all 4 tires are registered. If not completed, ensure the procedure was done properly and that all 4 sensors are in working order. Continue again. Once started, the test cannot be stopped and will cause an error if attempted. This may cause TPMS lamp to stay on with no codes. In this case, registration must be done over. So if you start it by mistake and you don't finish it, the TPMS light will be on, and then you'll just have to register. Continue, and then it'll go through the test in progress. You go around the vehicle, the lights flash. When you get done, it'll say test complete on the screen. And last one we're going to talk about before we go on the tool is going to be HVAC actuators. So if you saw the lead video that I played before we started here, HVAC actuators, um, they move the mode doors and such inside there. So it is a reversible electric motor. Inside there is usually it's a plastic gear, so you have some sort of a gear reduction between the motor and the actual arm. Contains a position sensor as well, so the computer knows where it is. And it operates linkages for the recirc door, the blend door or doors, mode door or doors, etc. Any of the things that move on here. So here's an example. We got a mode door actuator there, and then we got an air mix door actuator there. So it'll do the hot to cold. It'll also do the different defrost, floor, vent, that sort of thing. Oftentimes, though, like I said, with this fact that it's got a plastic gear, it can break, especially if you have any sort of mechanical issue in there. So you can see the broken teeth there, missing teeth. So in that case, it would need to be replaced. And when it is replaced, you need to do a reset or recalibration, or a relearn, as they would call it. So there is a relearn for that under service resets and relearns once again. And then we see if we look down here, we have replace or relearn an HVAC actuator. So if I replace the actuator in here, and this is once again on 17 GMC, we go in there, and then we go to functional resets and calibrations. But before we do that, I haven't mentioned this yet. If you're in the service resets and relearns menu and you have Shop Here Mitchell, you can link right to that from the tool as well. So there is a repair information, and then air conditioning actuator replace. We'll choose that. And then there's an R&R procedure. There's also an after repair info. If you ever see after repair, that's going to tell you there is a reset, there is a relearn, something that needs to be done. We can go in there. And then this is the actuator recalibration, which is a preferred method with the scan tool. So they prefer that you do it this way. Using a scan tool, perform the HVAC actuator, learn the HVAC control module, follow the scan tool directions, etc. So we would go in here. We can go into functional resets. It's going to give us the list. Now, like I said, it doesn't just give us resets and relearns anymore. It also gives us any of the bidirectional controls we might use in the diagnosis of this issue as well. So it can change the mode door position, mode door actuator positions, etc. after blow. But actuator recalibration in here is where we want to go, because we want to recalibrate the actuators. Use this procedure after replacing one or more actuators. When replacing the HVAC control module, the self-calibration procedure starts automatically after the module is replaced and the engine is started. Do not adjust any controls in the HVAC control module while the self-calibration procedure is in progress, or improper HVAC performance may result. Calibration process may take up to 40 seconds to complete. And to make sure the transmission is in park or neutral, start the engine and select calibrate on the following screen. So we'll continue. And then the procedure will be in progress. So they set up to 40 seconds. Once it's done, procedure is complete. Cycle the ignition and make sure it works. Hit exit. And we're done. Easy enough. All right, let's take a look at a couple examples on the scan tool. All right, got my Zeus Plus up here. Let's look at my first one. Here's a BMW. BMWs and a lot of European vehicles, just in general, have a lot of resets and relearns that need to be done, depending on what you have going on with the vehicle. You know, they're fairly complex. They have an awful lot of different computer systems, and in my opinion, you know, the especially the German cars, they tend to over-engineer everything. So maybe you'll see a lot more resets and relearns on European cars. Really, in Asian cars, you don't see a ton. Maybe a few here and there, like throttle body, oxygen sensor again on that one, on Nissans too. But by and large, the majority of them that you see, or at least the more complex vehicles, are going to be on these European cars. So you'll see there is an idle learn procedure there that there is available. Let's see what else. Let's see. Oh, here was an interesting one that I saw when I was looking through these. Replace or relearn seat. So if I do any seat work, on this vehicle. And it's got a power seat, recline and forwards and backwards and such. We go into functional resets. We can see that there is a lot of different things going on with the seats: the seat angles, seat adjustment controls, drivers and passenger sides. These are all the bidirectional controls here. But then if we come down here, we have seat initialization. So if we go in, it's going to be called seat standardization or normalization. Let's go in here. The driver's seat is standardized in the following step: information on seat standardization. Only carry out seat standardization on a trouble-free system. Make sure there's no codes, in other words. Make sure vehicle voltage is greater than 10.5 volts. The adjustment travel path must be free of obstructions. Do not operate the seat adjustment switch during the standardization. And also, the anti-trap mechanism is not active during seat standardization. So don't put your hand in there and don't get injured. Important: during normalization, the head restraint can collide with the headliner or sun visors if the driver's seat happens to be in the wrong position prior to initiation of the normalization procedure, such as the seat and head restraint both in extremely high positions. Before the normalization process is initiated, it's essential that the following steps be carried out manually in order to eliminate the possibility of a collision: adjust the head restraint to its lowest position, manually adjust the driver's seat to its lowest height, and then fold down the sun visor to its forwardmost position, and then we'll go next. And then it's going to go through this seat standardization procedure. It's going to take more than a few minutes, so we're not going to finish the countdown here. But in real life, if we were hooked up to a car, we'd be able to watch the seat move forwards and backwards and up and down, and the seat back might move forward and backwards, something like that. So it's just going to tell you how long it's been going, and then when it's done going through its whole realm of travel, then it's done. So I got to back out of that car in order to get back into it because the test was running. All right. And the next thing we want to talk about is, replace automatic transmission fluid. There's another one. So it's a maintenance task. So I need to do a reset, relearn type of thing with this automatic transmission fluid. So if I go to functional resets, I'm just going to pick the first one. And the test is called oil balancing. So the oil level in the automatic gearbox can only be adjusted when the following conditions are met. The idle speed needs to be between 550 and 800. Transmission fluid temperature needs to be between 30 and 40 degrees, and that's Celsius in the initial condition. And then transmission fluid must be between 30 and 50 degrees Celsius once again in the final condition. So this is interesting how they set this up too, because they have multiple reasons that this may need to be adjusted. So why does the oil level need to be adjusted? I guess they're probably assuming it's a sealed system normally, but are there faults stored in the transmission? And it'll give us an oil level check. The mechatronics or the converters have been replaced, or parts have been replaced, not the mechatronics or the converters. So let's assume that, maybe we just need to check the oil. So raise vehicle and hoist such the wheels turn freely, apply the parking brake and start the engine. Current transmission fluid temperature is shown on the following screen. Make sure it'll be continued automatically when it's between 30 and 40. And what's going to happen here is it's not going to be between 30 and 40 because we are on a simulator. So it says it's way too high. So it's not going to work until it gets down to that 30. So once it was there, though, it would proceed through the procedure and then give you the results at the end. So that's a couple examples there. Let's see if we can find one more. Let's see. Looks good. There's the idle learn procedure again. Let's see. Bleed the anti-lock brake system, or relearn the anti-lock brake control module. There's a relearn there. So they can do the adjustment of the DSC unit. Okay, service function must be performed if the DSC control unit's been replaced or you have any of these faults stored. The valve activation inside the control unit is adapted to the hydraulics. So they're separate. Most ABS systems nowadays, you can get just the control module or just the hydraulic module. So it's not necessary if you replace the whole unit, but only if you replace either the hydraulics or the unit. So they need to be adapted to each other. And the next step, the adjustment is started. Routine runs automatically. Brake pedal must not be operated, and we'll continue. And then it'll do an adjustment period. Takes about 10 seconds, it says. Let's see what happens. I think it gives me a fail as well. Gives me a fail because it could fail because the brake pedal was touched, or if there's air in the brake system, or in this case, because we're in a simulator mode and we're not hooked up to a car. So continue, and there we go. All right, so that's BMW. And then one more, we'll look at this GMC Acadia. So let me give you another example. So we have the oxygen sensor example I gave earlier, but another example could be the brake switch. So on these vehicles, it's no longer a brake light switch, so to say. It's a brake pedal position sensor. What happens when you replace it? It not only gives it, not only sends a signal to the BCM to turn on the tail lights and whatnot when your brake lights, but also it tells the the traction control and things like that. Where is the pedal in travel? How fast is the driver pushing it, etc. The engine needs to know some of these things too. So if I replace it, I need to actually reset it in two different places. Now, I could go look through the different modules and try and find the reset on any of those different places, but it's much easier to just go through here and let's see, go to brakes and then replace or relearn brake pedal positions. Let me actually go into repair information. So from what I remember, I need to replace it. It is going to tell me in after repair what I need. So brake pedal position sensor calibration must be performed after the brake pedal position sensor body control module or engine control module have been serviced. Calibration procedure will set the brake pedal position sensor home value. So where is it at default? Value is used by the BCM and the ECM to determine the action of the driver applying the brake system and to provide this information to the vehicle subsystems via serial data. So it's going to say apply the parking brake, ignition on, engine off, put it in park, install a scan tool, clear the DTCs, navigate to the BCM and then do the reset, and then go to the ECM and do the reset. So if I knew I needed to go in those two modules, that's great. But if I didn't know I needed to go in those two modules, I can go in here, and what it's going to do is it's going to pull the one from the engine and the one from the body control module on the same screen. So I don't have to root around in the different lists in the different modules trying to find it. So we're going to go here, key on, engine off, park or neutral, brake fully release, select learn, and it's going to start the procedure. So we'd hit learn and then be done. Simple reset. And then over on this side, same thing. So we'll hit continue, we hit learn, and then we're done. But you have to do it in both. Right? So you have to make sure that you do it in both of those sections. Otherwise, it can cause issues down the road. All right. So that is resets and relearns. So hopefully you got a couple little tips and tricks that you might be able to use there. The service resets and relearns function, if the tool doesn't have it, the individual modules will still have the resets and relearns available inside them. It's not like they change between the tools. It just makes it easier to find, especially when it's that job based, like for the example of that brake pedal position sensor. Brings them in from any of the modules that are related to it that might need to do that reset all in one place. So it's a time saver is what it is. But also worth the time to go in there and see, did I do any of these things? Right? Did I do any of these things? And what resets, relearns, or bidirectional controls might I need in order to get that done, or after the fact if I need to do that too, like relearn the liftgate actuator. So it's got a power liftgate. If I need to recalibrate that, I could go in there as well. Same thing with ADAS, right? That's a biggie. If I want to replace and calibrate the camera, that's in there as well. So loads of resets and relearns available on vehicles. Just the big point to take away is always check and see if there's one that needs to be done after the repair that you. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free, once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully we'll see you next week. Hopefully you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.